Repeat it again. Effect of Q. Okay? Now, Q is a value that determines the horizontal shift Okay. Whenever we talk about horizontal shift, there's one question that must come into your mind. What's being shifted? Okay? Because we cannot talk about shift without talking about what's being shifted. Okay, so here you'll be shifting the graph. It's exponential of the form y. Okay, let me use a different color there. The graph of y equal to a times b to the power of x. So this is the general or the basic exponential function that you will be shifting. Okay, of course, don't worry about the value of a and the value of b at this stage. It's just a general formula. So shift of this. Okay, remember, if q is greater than 0, the graph moves upwards. Okay, you know this already. And then if q is less than 0, the graph moves downwards. So it's not graph, it's supposed to be graph. Okay. Remember, the graph that we are talking about is this. Yes. Oh, sorry, it's vertical. Sorry, vertical. You know that I'm teaching functions as well to grade 11 now. So maybe my mind is also there. All right. So the graph moves upwards. Okay, if q is less than 0, the graph moves downwards. Right? So make sure you remember this. I've spoken about it when I talked about the quadratic function, the type of order as well. So the meaning of the q is the same. Now, you also need to be aware that the horizontal asymptote is also shifted. Okay, it can be shifted up if q is positive or down if q is negative. Okay, so the asymptote also moves. Right. So then number 6. Now number 6 is the effect of A. Okay. Number 6 is the effect of A. This A here. You need to know what it does. Can I move to the next page? So number 6, effect of A. Well, okay, the way that I'm going to explain is this way. The sign of the value of A determines whether the graph will curve downwards or upwards. Okay, so I'll write here the sign of the value of A determines whether the graph curves upwards or downwards. Okay, so we have got two cases there. If A is greater than 0, the graph curves upwards. And remember, the graph that we are talking about here is y equal to a times b to the power of x. Okay, so the graph curves upwards. Okay, I'll show you what I mean by this, because you haven't studied this graph before. Then number two, if a is negative, the graph curves downwards. Right? So make sure you are aware of this. Up to metric, you have to know it. And even beyond, if you start something that has got maths. Okay. Can I move on? All right, the next thing now, we'll talk about the effect of B, but I'm going to combine the effect of B together with A and Q. So I want you to write this heading, number 7, effect of B. So that of effect of B. Now, for B, now B has got two cases. The first case is when B is greater than 1. Okay, so this will be case 1. So I'll write here case 1. Now, when B is positive, because B can never be 0, otherwise, if B is 0, then the exponential function doesn't exist. So if B is positive, right, we have got two possibilities for A, two for Q. Let's start with A. If A is negative and Q is positive, the graph will look like this. Okay? Remember what I said earlier, that A determines the the curvature of the graph, or you can say the steepness if you want, right? So if A is negative, the graph will curve downwards, right? If it's curving downwards, and if the asymptote or the value of the asymptote is positive, then it means that curve will be drawn below the asymptote. If A is positive, right, and Q is positive, we call this an increasing function, and this was a decreasing function. Remember, I spoke about increasing and decreasing functions before. So if A is positive, then it's going to be an increasing function. If Q is positive, then you're going to have the curve being drawn above the horizontal asymptote. Okay? Then if A is negative and Q is also negative, both the curve and the asymptote below the x-axis. And since A is negative, there will be a decreasing function. But the asymptote is going to be above that curve. Okay? So whenever A is negative, then we are going to have a decreasing function. Okay? And when A is positive, we have an increasing function. This is very important. Okay? And then if A is positive but Q is negative, whenever Q is negative, it means the horizontal asymptote will be below the x-axis. Whenever the value of Q is negative, it means the horizontal asymptote will be below the x-axis. Okay, but if A is positive, then it will be an increasing function. Therefore, the curve is drawn above that horizontal asymptote. Okay, so this is the first case when B is positive. Okay, what I mean there, just to emphasize, for general equation, it's y equal to a times b to the power of x plus q. So here I'm mainly talking about this b. That b there. It can never be 0. But when it's more than 1, then you are going to have n of these 4, depending on the signs of A and Q. So we have n of those 4. Okay, don't worry, in a few minutes time we'll sketch some exponential laws. Right, then case 2. Now this one is when the value of B is between 0 and 1. The value of B can never be negative. The value of B can never be negative. It's always a positive value. Okay? So this will be case 2. When the value of B is a fraction between 0 and 1. Okay? When that happens, if A is negative now, this is actually the opposite of what we're talking about. If B is greater than 1, then when A is negative, we'll always have decreasing functions. But with this case now, if B is a fraction between 0 and 1, when A is negative, we are going to have increasing functions. So it's the opposite of the value of B, which is greater than 1. Okay? And then when Q is greater than 0, obviously the asymptote is going to be above the curve. So it will look like that to be an increasing function. But the asymptote is going to be above that curve. Alright? Then when A is positive, now we have got a decreasing function. Now, this is being caused by the value of B now, or it will be caused by the value of B. So we have a decreasing function here. Right, let me just add this here. Please, this is case 2. So here I'll write here, increasing function. So let me use a different color. So that will be increasing function. Okay, sorry girls, what's happening? Okay, so for case 2, it's going to be the opposite. Okay, for case 1, when A is negative, the graph will be decreasing if the value of B is greater than 1. If the value of A is positive for case 1, we're going to have an increasing function. For case 2, it will be the opposite now. If A is negative and B is between 0 and 1, we're going to have an increasing function. If A is positive and B is between 0 and 1, we're going to have a decreasing function. Okay? The Q value does not determine whether the function is going to be increasing or decreasing. Okay? For a function to be increasing or decreasing, it depends on the value of B and the value of A. Okay? Right? Then here, when A is negative and Q is negative, we are going to end up having a decreasing function. Or sorry, an increasing function. And then when A is positive but Q is negative, we also have an increasing function. But the asymptote is going to be below that curve. All right. Now, you have to sit down and be familiar with case 1 and case 2 of exponential functions. So, any exponential function that you are going to encounter in this grade, it will look like this, like n of these 4, or n of these 4. So, total 8. Okay. So, n of those 8, that's how your exponential functions in this grade are going to look like. Right. Any questions before I move on to an example? Like, I'm going to show you some animations just now with regard to what I was talking about here. I think, let me show you this part. Then after that, we'll do some sketching. Okay, supposed to have the y. Well, f, I wonder why. Okay, f. Okay, can I have your attention? So we'll put a times b to the power of x, okay, plus, well, let me put a value for b. All right, can I have your attention? Can I have your attention? So here we have got a value for b, which is 0.2. Okay, that's a fraction between 0 and 1. Okay, so I just want you to look at this. Okay, can you please have one lesson? All right, let's start with changing a. I want you to look at what's going to be happening. Okay. Okay, let me make it. You think so? So, what do you want me to do then? Because listen, I want to show you the effect. Okay, I also need to add my asymptote. Yeah, but you see, in this case here, I can't add the asymptote, but what I can do is I can write it as q right. What you can do, if you find some time, just download the graphing calculator from GeoGebra and then you can play around with it. Okay, just bear with me. I need to change my equation. All right. It's not allowing me. I think I need to figure something out here. It's not allowing me to change the value of b to a value more than 1. Can you have one lesson? I think we need to put glue on your mouth now. All right. Let me just go back and sketch some graphs before the lesson ends. Okay, so can you write examples? Examples. Right. I'm going to sketch the following together. So we'll start with y equal to 2 to the power of x. Right. We'll sketch it together with y equal to 2 to the power of x plus 1. And then we also sketch 2 to the power of x minus 1. Okay. All right. Let's just use a table. Let me draw up a table. Since we have got 3 functions, please, I'm only doing this because this is your first time to do this function. In future, I'll sketch it without a table. So let's say values of x. We only take a few values, 5 values. Say minus 2, minus 1, 0, 1, and then 2. So for y equal to 2 to the power of x, and then we have got y equal to 2 to the power of x plus 1, and y equal to 2 to the power of x minus 1. Okay. Let's find the y values. So when x is minus 2, if you put minus 2 there, you get 1 over 4. Right? And then the other one will be a half, then 1, then 2, then 4. And then now please be aware that there is a relationship between these 3 graphs. You don't need to substitute x equal to minus 2 here. It's not necessary. Since there's a plus 1 here, I'll just add 1 to this quarter. Right? Are you following that? So you get 5 over 4, and that will be 3 over 2. That will be 2. That will be 3. Remember, this plus 1 here, it means we are moving y equal to 2 to the power of x by 1 unit up. Okay, so the y value is increasing by 1, right? Then I'll add 1 to that, you get a 5. Then, for me to get the y values for y equal to 2x minus 1, all I'm doing is I'm subtracting 1 from the y values of that row. Okay? Are you following? So, a quarter minus 1 will give me minus 3 over 4. A half minus 1 will give me minus a half. Then 1 minus 1 will give me 0. And then 2 minus 1 will give me 1. 4 minus 1 will give me 2. So all I'm doing is I'm subtracting 1 from the y values of y equal to 2 to the power of x. To get these y values here, y equal to 2x plus 1, I just added 1 to the y values of y equal to 2 to the power of x. Alright? Now, I now need to plot this and then I can sketch them. We have to at the time. Right. Let me do it properly on a graph. Okay, my minimum is -2. Okay, so let me take this. Okay, my y values are maximum is 5, minimum is -3/4. Okay, just give me a second. I need to adjust my